All right, the third amino acid in the list is serine, making up about 7% of the amino acids in proteins. Let's draw it here. So again, I'm just drawing the starting point for all amino acids. Right, and the serine side chain is going to be a methyl group with a hydroxyl group. I usually think of this methyl group here as like spacing. You wouldn't really have a functional group attached right to the stem of the protein. So there's a lot of, pretty much everything has a carbon at this point that has various branching or you know, atoms attached to it. And here's the 3D model again. I've already searched for it. L serine, just be explicit. Here's the alpha carbon and the side chain. And yeah, there's a lot of red. You can see 3 oxygen atoms in the molecule here. And then here on the left is the N terminus, on the right is the C terminus, and this top here is the side chain. I didn't bring this up before, but here's a list of pretty much any functional group that's defined. In biology, there's definitely a subset of this that comes up much more than anything else. So in a biology book, it'll be a much simplified table of functional groups. But here's the hydroxyl group, just a OH attached to some the remaining molecule off to the side here. On the serine page, they call the side chain a hydroxyl methyl group, so they're kind of combining the methyl group with the hydroxyl group. But I think the hydroxyl group is really the key to the function of the molecule of the amino acid. I'm going to try to mention this for all the amino acids, but the 3-letter abbreviation is SER and the 1-letter abbreviation is S. It's kind of unnecessary for all the simple ones where these letters match what you'd expect, but might be a little useful later especially when the single letter abbreviation is some apparently random letter. So I'll try to make sense of that when it comes up. Serine is not essential. There's various ways that the body can make it. This section here on biosynthesis is a little complicated, so I'm not going to go into it. The word serine comes from the Latin word for silk. Cerisum, maybe? Because that was one of the first discoveries of it was in the silk protein. And you can see here just a left-handed version and a right-handed version. And there appears to be some signaling, like cell signaling features of the right-handed version, but I believe that the left-handed version is still the only thing that shows up in proteins. So one definitely useful use for this amino acid is in these serine threonine specific protein kinase. So a kinase, it's going to be some enzyme that can attach a phosphate group to a protein. And so the serine, I'll worry about threonine later, but serine, the hydroxyl functional group on that will easily attach a phosphate group. So I'll show you the picture of it down here. Here's serine again as a simplified skeletal view or whatever that's called. And then a phosphate is phosphorus with the 4 oxygens and the double bond, and usually there's like some, these are negatively charged in the cell. So here's phosphoserine. You have serine here on the right, and you have the hydroxyl group here, and through a dehydration reaction, you've attached the phosphate to it. So if you have a molecule that you need to, if you have a protein that needs to get phosphorylated, having a serine amino acid at the right spot is a good way to do it. So let me just actually draw that on here. So again, here's the side chain, and if you had a phosphate ion floating around, maybe forget exactly what it would look like, but here's something definitely close to what it would look like. So what you're going to have is a dehydration reaction where this oxygen here is going to get removed as a water molecule, and say this oxygen here will end up binding to the side chain. So what you have here is your thing they call it a phosphoserine. Go back down there. Yeah, phosphoserine. Where you have, in a protein, you have this kind of continuing on. There'd be a sequence of amino acids connected together as a peptide or a protein. And here at the side chain, you can attach the phosphate group. And then it is, by itself, it is hydrophilic, so this will be exposed to the cytoplasm in the cell. And just, like I said, a common function of this amino acid is to help attach a phosphate group to a protein.